Okay, so let's look at the problem. All right, this is the drip factor. So it says right on there for you that you're calculating the drip factor. Now, the only difference between this and the questions that you see on the quiz, okay, is the format of the question. But the question's still asking you the same thing. All right. So if you look here, it's saying, for you to calculate your drip factor, basically. All right. All right. So what do you need to calculate the drip factor? What are the main things that you need? We're going to take that out of the question, and then we're going to go to the whiteboard and we'll do the math. So what is your formula for drip factor? Okay, I'm going to say it to you, and I want you to write it down. Okay. It's total volume over total time in minutes. So you're going to divide that by the total time in minutes times your drip factor. And it's always going to be a whole number. Okay, so that's part of the formula. Always a whole number. All right, so if it's total volume, what up there represents volume? So whenever you're looking for volume, you're going to look for something that either says milliliters, liters, kiloliters, anything that ends in liters, because that is going to be your volume. All right. So for here, what ends in milliliters?
1500 ml.
Okay. So that's going to be your volume. So take that number. The next thing you're going to take is your time. So your time here is 12 hours. Now, it has to be converted to minutes, but for now, we're just going to write down 12 hours. And then our drip factor is 15 GTT per ml. Okay, now let's go to the other screen. Come on, whiteboard. Can you guys see the whiteboard?
Yes, Professor.
Okay, I'm just waiting for it to actually get to a point where I can use it. It's still loading. On Zoom, things don't like to load that fast, so. Okay, so I always like to write my formula over here. All right, so total volume over total time in minutes times my drip factor, always a whole number. And I say that because the question may not tell you to round it. You need to know to round it to a whole number, okay? All right, so we had 1,500 mLs. That's our total volume. Our time has to be in minutes. We know we had 12 hours. So we're going to multiply that times 60. And that should give us like 720 minutes. Is that correct?
Yes, yes, Professor.
Okay, so we got 720 minutes. Okay, and then we have our drop factor, which is what, 15?
Yes, Professor. 1500 divided by.
Okay, we want to get to drops per minute. Okay. So here you have mLs and here you have mLs. You're going to be left with drops per minute once you do the math. So 1,500 divided by 720 is what?
I did 1500 divided by 720 times 15.
Okay, what'd you get?
I got 31.25.
Okay, 31.25.
So it has to be a whole number.
Right. So this is your 100th place here. This is your 10th place here. This dictates the whole number. This dictates if you were rounding it to the nearest 10th. And if you had another number here, that would be your 100th place. And that would dictate what your, that would be the 1000th place. And that would dictate what that number would do. So if you're rounding this to a whole number, what are you going to round it to?
31.
Okay, good. And let's go back to our
Why is my screen like this?
main screen. Oh, 31's up there. How about that?
What is it? Oh, yeah, 31 GTT. Okay.
All right, look at your second problem. Now using the same math, see if you can calculate it.
Okay, where is it? First one. Where's the second? Okay, let's see.
Remember what your formula is. If you know your formula, it doesn't matter what the problem says. How we doing?
Okay, I think I got it.
Okay, what did we get?
150 GTT.
Good. Was everybody able to get to 150?
Yes.
Perfect. All right, here's another one. Now, what's the difference in this one?
Leader.
Number 3.
Yeah, what's the difference with this problem versus the one you just did? For one, look at your time. Your time is in hours, right? So you're going to have to convert that.
Oh, convert
Now
that to minutes. Yeah.
Yeah, now look at what your order is. You have two 250 ml. So you have to make sure you do that math there and put
Oh,
your
yes.
whole 500
It's
mLs
500.
there. Okay?
Um,
500. 240.
What do we get?
31.
Perfect. Okay, how about number 4? Now look at number 4. Number 4 is a little bit different too.
Yes, we have to convert to 2 liters to milliliters.
Okay, what else?
Let's see.
MEG.
Oh, 48 hours to minutes.
Okay, hours to minutes. You don't have to do anything with the strength. MEQs is a strength, okay? And for this formula, we never need a strength. Always volume over time. Remember that because when you're looking at the questions, you're always looking for something that I said that has liters or milliliters to it. It has MEQs next to it. If it has milligrams, micrograms, we don't need that for this question.
Oh. Thank you, Professor. That has always been my
That-
problem.
that-
I always get confused there.
That's
With
where the confusion comes in.
That always confuses the strength.
So remember that your volume, let's just explain this, okay? If you're going to give potassium chloride, especially of all drugs, you can't put that directly into someone's veins, right? So
Right.
you're going to dilute that in a bag of normal saline usually. This one, they put it in D5, probably because the patient has some other issue. Because D5 half normal saline is a hypotonic solution. So if they were trying to move fluid into the cells, and that might be what they're doing here because they want to move that potassium into the cell. Because potassium is supposed to be in the cell, right? That's where it likes to live. It's kosher. It likes to live in that cell. So they're giving it with this D5 to try to move that fluid into the cell. Okay, that strength is just the amount of potassium that they've diluted into that fluid. That fluid is actually your vehicle that's bringing that potassium into the body. So it's diluted, and you have to know how much of dilution on some questions is in each ml in order to calculate certain questions. So it's not really fluff. If you were given a bag of potassium chloride, this is how it would be given to you mixed in this amount of fluid, and you would have to determine like how many mLs per hour are you going to give safely for this client so they don't go into cardiac arrest while you're giving this drug. Okay, so the whole thing of calculating the drip factor is if you were working, like when I worked through Hurricane Sandy, I had 150 patients living in a gym. We didn't have electric. So we had to calculate all our IVs by gravity. Now, really, if you had a pump, you would set the pump to mLs per hour, right? But since you don't have a pump here, you can't. But you still need to deliver the medication at a certain mLs per hour in order to get the dosage in there right. So in this case, we count out drops. Okay. Now, let's say you were given, because you did have a problem on there that said, let me just go to the whiteboard for a second. Come on, whiteboard, be faster than that. I'm not paying you by the hour. Okay. So you probably saw a problem on there that said you have a drop factor of 17 drops per minute and tubing with a factor of 20 drops per ml. And what we said is we want to know mLs per hour. So really, that's why you calculate drops per minute, because you're really trying to get to mLs per hour, but they don't tell you all that in the dosage count question. Okay. But if you're trying to figure out what is my mLs per hour here, you can use your drops per minute to get to that. So if you have 17 drops per minute, how many would you have in an hour? So you would just take your 17 and multiply that times 60, which would give you how many drops?
17 by 60 will give you 1,020 drops.
So now you have 1,020 GTT, right?
Yes, Professor.
Per hour.
Mhm.
And your tubing factor is 20 GTT per ml. So when you do this math, okay, your drops is going to cancel out here and you'll be left with mLs per hour. So you're actually just doing like the drip factor backwards here. So now do that math and what do you get?
Divided by 20, you get 51.
So it would be 51 mLs per hour, and that's what your pump is running at. So if you had your pump running at 17 drops per minute with this tubing factor of 20, then your pump is actually running at 51 mLs per hour. But it's not a pump, it's running by gravity.
Okay.
So I want you to know that, because sometimes if you understand why we're doing it, then you understand the concept better.
Mhm.
Where's my share? Okay, look at number 5. Now, again, you need 3 things to answer this question, okay? Always. Total volume, total time in minutes, and the drip factor. In here, you're lucky because it doesn't give you any strength or anything. So you know what do you have to do here to solve this?
I did that already.
Liters to mLs.
Okay, convert those liters to milliliters, and all you got to do is bounce your little
Hours to minutes.
decimal over twice, right? 1, 2, and that'll give you 400 milliliters.
Divided by 240.
Okay, it's 3 times 60, so it'd be 180 minutes, right?
180, sorry.
400 divided by 180 times your 10. What'd you get?
22.2222.
So,
22?
Yes, Professor.
Okay. Here's another one.
Okay, let's try that. 0.5. 6 hours, that would be 3. 6.
What'd we get?
Coming, Professor. 50.
For number 6? Or are you doing number 7?
42.
Number what? Number 6? Oh, wait. Oh,
Yeah, we were doing number 6.
Oh, 45. Okay. Um, three factors, what?
42.
What did I get wrong? What did I do wrong? What was the number of hours? I can't see.
Were you
Is
looking
it-
at number 6?
500.
My thing is blocked. That's why I can't see the complete figures. I don't know.
Your
There's a
screen is broke?
no, there's a black. Let me see if I can take it out.
Oh, you can just drag it away from there. Just grab it and drag it and move it to the side.
Oh, see, now I know where the mistake came from. I've realized it. Divided by 300 times. Oh, is it 300? No. Divided by 36.
Divided by 360.
360, exactly. I went and put 300 instead of 360.
Okay.
That's where the thought came from.
So how are we feeling about these now? You want to do a couple more?
It's 42. Yes, Professor.
Let's
It's
do
42.
number 9.
Mhm.
Number 9 and number 10. Do them both.
Okay. Number 9.
By the way, if you want to come back and practice those later, where's my chat box?
24.
Totally free. Plus, you have the video if you don't understand it, like if you need more dimensional analysis. I don't do dimensional analysis. I can't stand it. Even though people say that's my style, I don't think so. I do a formula style, but they say I use dimensional analysis because I cross stuff off, but there's certain steps I just do in my head.
Mhm.
That's very good.
21.
Mhm.
Okay, so you got 21 for 9. That should be correct. And
And
what'd you get
17.
You got 17?
for 10? 17. Okay, very good. All right, let's see how you did.
I smell 100.
We skipped a question, otherwise a couple of questions. So
Yeah.
let's see how we did on the ones that we did submit. So they want us to give an
I
answer.
did,
So
I did number 4 though, and I got 10.
number 4, you
I
got,
did it.
oh, where'd
I
it
got
go?
10.
Number 4, you got 10. Okay.
Yeah. Yeah.
But I didn't see the other
Let's
ones.
let's
I
do
didn't see
7 and 8. Let's
Yes,
do
Professor.
7 and 8 so you can get your 100.
7, 8.
7 is 50.
Where's the question? Oh, let me see. Hold on, Professor.
Okay, no problem. Take your time.
Professor, we had 2 math drip factor in our last test.
Okay.
Yeah, I would like to go over it. I don't know, but yeah, it was completely different from what we're doing. Our
Okay.
last,
All right, we'll take a look at it.
okay.
What we get for 8?
We are coming, Professor. 1 second. Almost there. 8 is 18.
Yeah.
Okay.
I wish this is what is coming to test. Right.
so easy right now. I'm
Yeah.
gonna get to the top.
Oh, look, you got 100% rock star.
Yeah.
Yay.
Yay.
All right, so let's see. Let me stop my recorder for a second.
Yeah.
Okay, is this one of the questions you're talking about?
Yes.
Yes.
Okay. So remember what I was saying is when you're using a gravity drip, you don't have a pump. That's why you're using the gravity drip, and you're actually counting drops per minute to actually set the pump for mLs per hour. Okay? So in this question, what is this question asking you? What is the rate in mLs per hour? Okay? Now look at in your question, what do you have? What's given? Okay?
The time, the total time per minute.
Okay, so we're giving 15 drops per minute, so write that down. And our tubing factor is 20 drops per ml. And it's asking us for mLs per hour. So those are your givens in the statement, okay? It's most important that you read every question from the very last statement in that question. And this one says, what is the rate in mLs per hour? Because that tells you how to set up the formula. Everything else in that statement doesn't matter until you read that part, okay? All right, let's go to the whiteboard. Whiteboard. Okay, so then down here, I'm going to put what I want to get to, which is mLs per hour. Okay, I know that I have 15 GTT per minute, and I know that my tubing is 20 GTT per ml. All right, so first thing I have to do is convert this minutes into hours. So how would I do that?
16.
Multiply by 60. So I'm going to multiply both sides by 60, okay? And that's going to give me what? 15 times 60 is what?
900.
Okay, so that's going to give me 900 GTT per hour now. Because I multiplied this times 60, so this converts now to hour, okay? All right, so now my GTT is going to cancel out, and what am I going to be left with?
Milliliters.
mLs per hour. So now you just have to do the math.
Professor, I thought you said you were going to multiply both sides by 60.
Yeah.
So you don't multiply the 20 by 60?
No, both
No,
sides
that's-
of
oh,
15 drops per minute.
Ah, I got you. So 900 over 20. Wow.
So now you're left with 45 mLs per hour.
That was a little difficult.
I don't think it's difficult. I think it's just confusing.
You're
No, we
just
need to
going
do-
backwards there.
Professor, we need to do more of this one. This one.
Yes,
Yeah.
this
This
one
one
was
is a
hot.
real one.
Everybody failing that test.
This is the real one.
I didn't know what to do when I got to it. Oh,
Professor, this is the real one to study. No.
All right, let me go.
Need more practice on this one. Wow. So you see 15 GTT per minute, convert the minute to.
Okay, you see the first one?
Not yet. It's coming. We're waiting.
You should see 5 flow rate questions on there. You don't
It
see
is-
them?
It's
Not
still
yet.
dark. It's still dark. Nothing is showing yet. No whiteboard.
Okay, try it again.
Okay. Okay, we got it, Professor.
Okay.
Let's see, calculating. You want us to try it?
Yep.
So the first one we did it.
You did it? Oh,
Like
that's
I'm-
what we just did.
Oh,
The
well,
first-
let me just change the numbers then real quick.
Yes, Professor.
Okay, there you go. Now you got a new question. So let's start with the first one and we'll go over it one more time, okay? Just to make sure you understand it, okay? So it's asking what is the rate in mLs per hour. So first thing you have to do is take what you have given in the statement. So you don't have anything in hours, but you have something in mLs, right? So in
Right.
mLs, you have 15 drops per ml. Now you don't have something in hours, but you have something that can be converted to hours, which is your 13 GT
Minutes.
per minute.
Minutes.
Okay. All right, let's go to the whiteboard and then we'll come back to that main screen. Once we do this practice, we'll come back to the main screen and you'll try to do a couple of those.
Mhm.
Or
Oh,
all of
it's
them, I don't care.
cool. Why do it seem so hard when you're doing it though?
Well, if you know the formula, okay, understanding the formula. I'm a formula person. I just try to keep things very simple. I like keep it simple, stupid kind of math because I don't want to have to rack my brain to solve a problem.
Mhm.
Right. Okay.
Okay, and most math problems I can do in 45 seconds, regardless of how difficult they look. Because it's understanding what the question is asking you and plugging in that formula. So that's why I always read my questions from the bottom.
Mm.
Right.
All right, so we have 13
Times 60.
GTT per minute.
Yeah.
Come on.
Mhm.
And we want to get to mLs per hour. We have 15 drops per ml.
Mhm.
Okay, so first thing we have to do, because we're getting to mLs per hour, this is where we're going to. You know that you have mLs, but what you don't have is the hour. So you have to convert now. So in order to convert, we're going to take our 1 minute here, okay, and multiply that times 60. If you multiply this side by 60, then you have to multiply this side by 60. Okay, so 13 by 60 is what?
780.
Mm-hmm.
I think I got to get a smaller pen. That one's not working that great.
780 divided by 15 is 52.
Okay, so 13 times 60 was what?
780.
7. So we had
Eight.
780.
80 divided by 15.
Now we have drops per ml. I mean, drops per hour, okay?
Mm-hmm.
Oh,
So
okay.
now we're going to cross out our drops. And it'll leave us with mLs per hour.
52. 52 mLs.
Okay, 52. Is
Mhm.
everybody able to get there?
Yeah.
One more, please. My computer went off. My
And
battery.
we're going to do a couple more, actually.
Okay. All right.
All right. So let's go back to the board with the questions. And here we go. Okay, you got 4 of them there. Right here. See if you can calculate these 4. Okay, I'm going to give you a few minutes.
Okay. You want us to do all 4?
I want you to do all 4.
Okay, Professor, we're coming.
$100. $43.
We're still working. Don't say the answers.
Okay. You're still on these last two?
I'm doing the last one. Don't say the answers yet.
Okay.
Now you can say it. I can even say mine now.
You're done? Everybody else is done?
Mhm.
The last one is 96.
60.
I have a question about that .2.
0.2.
Would
So
that still,
on the test, I'm going to tell you what I want you to do with that. I'm either going to tell you to round it to a whole number or round it to the nearest 10.
But you said in drops, you cannot use the point.
Are we doing drops?
no, we're-
No,
What
We're
are we
doing
doing?
mLs per hour,
Oh,
right?
MS. Oh, look at me. I took the 2 out. Okay.
Well, you weren't wrong to take the 2 out. Like if I didn't give you direction here, I would accept either answer. I would accept 43.2 because here's my question, okay? Now,
Mhm.
when we're doing drops per minute, why do I tell you it has to be a whole drop? Because there's no way for you to give a partial drop. I don't care what kind of scientist you are, you cannot give part of a drop, okay?
Mhm.
For
Alright.
mLs per hour, can we set a pump to the nearest 10?
yes,
Per
Can we set one to the nearest 100?
yeah.
Yes, because we can use those pumps in critical care.
hour.
So in an answer like this, I would either tell you to round it to the nearest whole number or round it to the nearest 10th. If I didn't give you any direction and
Did
you
you
put
put it as
either
it is,
answer,
right?
I would give it right.
Okay.
Okay,
Okay.
So we all had 100.
cool. Yeah.
Yes, you
Yeah.
all had 100 on this one. Everybody was able to get to all the answers here. Okay, what else?
That's it.
That's your struggles right there?
Yes, yes.
Okay.
Oh, but thank you though. I was worried about this one. Thank you.
Now I am very clear now with
Yeah.
the strength, not to mix up with the strength and the actual thing, the volume.
Okay.
But now I know
And
the
once
difference.
this video is uploads, I'll post it on YouTube.
All right.
Okay.
Thank you. Thank you. Thank
You guys know how to get to my YouTube channel. You just type in my name. I have all
You
kinds of
have
stuff on
you
there.
have a YouTube channel?
I
You have
do.
I never
Oh
knew that.
yeah, we didn't know that.
Oh, that's good news.
I have lots of stuff on there. I have recordings for L to R on there. I have recordings for care plans on there. I have recordings on there for all types of stuff.
Oh no, we're gonna visit that.
Oh,
Yeah.
so
So
rep-
it's just your
We should just type Miss Susan Losh.
If you just type in my name, YouTube,
okay.
here. All right, can you see my screen still?
Yes, we still see the whiteboard.
All right, let me fix it back.